Hey everyone, Professor Baldwin here. Today we're going to solve an absolute value inequality. Remember that absolute value is distance. So here we're looking at a distance less than 16. So what does that mean? That means if we're at some point, we can travel 16 units to the right or 16 units to the left. But we have to stay within that. So it's almost like this person's on house arrest. They can't go further than 16 units. Remember, when you go to the right, that's a positive 16. And if we go left, it's a negative 16. So we have two different inequalities to solve. Or we can set it up as a three-part inequality, where negative 4x plus 4, our distance traveled, has to be between negative 16 and positive 16. Remember, I really like three-part inequalities because it spits out our interval notation. Here we need to isolate x in the middle. So first we need to subtract 4 from all three parts. That gives us negative 20 on the left, less than negative 4x in the middle, less than 12 on the right. Now to get x isolated, we need to divide by negative 4, and we need to divide all three parts by negative 4. Remember, with an inequality, whenever you divide by a negative, you need to flip those inequality signs. I like to do that first. In the middle, we simplify to just x. On the left, negative 20 divided by negative 4 is a positive 5. And on the right, 12 divided by negative 4 is negative 3. Now, notice that this is a little bit wonky. We have 5 on the left and negative 3 on the right. You really want your interval to go from the smallest value to the largest value. So we just rewrite the inequality. It's like flipping it with a mirror. And so we have our final interval here, that x is between negative 3 and 5. So negative 3 to 5. And now we ask ourselves, are we using parentheses or brackets or a combination? Well, we have just less than signs, so they're parentheses. Remember, you only use brackets when you have an equal.